Here is our third problem, and it builds directly on problem 2. Same 4-element array, same half-wave spacing, same uniform amplitude. But now, instead of broadside, we want to steer the main beam to theta 0 equals 60 degrees. We need to find the required phase shift beta, write the new array factor, find the null angles, and compare the pattern with broadside. Let's see what changing just one parameter does. Step 1. Find beta. The beam points in the direction where psi equals 0. That's where all element phasors add in phase. Psi equals kd cosine theta plus beta. We want psi equals 0 at theta 0 equals 60 degrees. Setting up the equation, 0 equals kd cosine 60 plus beta. We already know from problem 2 that kd equals pi. So 0 equals pi times cosine 60 plus beta. Cosine of 60 is 1/2. 0 equals pi over 2 plus beta. Therefore, beta equals minus pi over 2, which is about minus 90 degrees. Our new phase parameter becomes psi equals pi times the quantity cosine theta minus 1/2. Step 2. Write the steered array factor and find the nulls. The formula is identical to problem 2. We just replace psi with the new expression. Quick check. At theta equals 60 degrees, cosine theta minus 1/2 equals 0. So psi goes to 0, and AF normalized goes to 1. Good, the beam is at 60 degrees. For nulls, we set the numerator to 0. N psi over 2 equals m pi. Substituting, we get cosine theta equals m plus 1 over 2. Now check each m. M equals plus 1 gives cosine theta equals 1, theta equals 0. But the denominator is also 0, so this is a peak, not a null. M equals minus 1 gives cosine theta equals 0, theta equals 90 degrees, true null. M equals minus 2 gives cosine theta equals minus 1/2, theta equals 120 degrees, true null. M equals plus 2 gives cosine theta equals 3/2, impossible. So nulls at 90 and 120 degrees. Step 3. Compare with broadside. The graph shows both patterns on the same axes. The gray curve is our broadside pattern from problem 2, peak at 90 degrees. The blue curve is the steered pattern, peak shifted to 60 degrees. Notice, the nulls moved from 60 and 120 in broadside to 90 and 120 in the steered case. Also, the beam is slightly wider, about 31 degrees instead of 26. This is normal. Beams broaden when steered away from broadside. Step 4. The polar pattern comparison makes it crystal clear. On the left, the broadside pattern with its beam at 90 degrees. On the right, the steered pattern with beam at 60 degrees. Same array, same elements, only beta changed from 0 to minus pi over 2. This is the power of phased arrays, electronic beam steering with no moving parts. Change the phase shifts and the beam follows. Here's the 3D view of our steered array. The beam now tilts towards 60 degrees instead of being perpendicular. 4 elements, half-wave spacing, just a 90-degree phase shift between elements, and the beam steers 30 degrees. Let's box our answers. Part A. Beta equals minus pi over 2 to steer to 60 degrees. Part B. The array factor uses the same formula with psi equals pi times cosine theta minus 1/2. Part C. Nulls at 90 and 120 degrees. Part D. Compared to broadside, the beam shifted from 90 to 60 degrees, widened slightly from 26 to 31 degrees, and the null positions changed. The takeaway: beta is your steering knob. Everything else follows from that single parameter.